Okay, so just want to kick off by saying a huge thank you to the Ethical Hacking Society for giving me the opportunity to speak today, especially the opening keynote. Today's talk will be focused on vulnerability reporting in open source software. So hopefully you find it interesting, learn something that you didn't know. I'm just going to start off with a little bit about who I am. So my name's Thompson. I'm a vulnerability analyst working for the Black Duck Security Research Team as part of the Software Integrity Group, which is one of Black Duck's main sort of business units. I thought I'd also talk a little bit about how I got into security because it's maybe a slightly non-standard route, but I think non-standard routes are becoming more common. So I was studying music technology, which sounds completely unrelated. One of our modules was focused on programming, and I really enjoyed that. I thought maybe this is something I could do as like a full-time job. So I started going to careers fairs and things and getting an idea of what was out there. Talked to a lot of different companies, and they said, we'd love you to come and work for us, but there's a sort of chicken and egg situation where if you don't have experience, then it's very difficult to actually get into a company. There was a conversion course offered so I went to Queen's University, Belfast, and there was a conversion course that they offered, but it didn't have a placement or any kind of industry-related aspect to it. So I thought, okay, what are my other options? So I decided, having finished my first degree, to do an entire second undergrad degree, and luckily I didn't take a student loan the first time, so I was able to kind of give myself a bit of financial help the second time around. But yeah, so I kind of from that point on, I was able to start to build up my skill set. I already had some experience. I've been programming for about 7 years now, so I kind of over time, I just got used to like a wider set of different tools and things. And so in recent years in Belfast, there's been this sort of explosion of different security companies from the US, especially coming over. So there's a lot of different reasons for that, but one of the big factors is that we have CSIT, which is the Center for Secure Information Technology, and they work, so they're the sort of like the research arm of Queen's, and they work with industry, and this has kind of helped to grow the talent pool, and give sort of like a good range of different candidates for jobs for all the companies that have come over. So we started going to fairs, talking to those kind of companies, and I was really interested in what they did, and I thought, right, let's sort of explore this in a bit more detail. And I started doing CTFs. Like, I'm sure like everybody follows this kind of trajectory, doing CTFs, things like BWAP and DVWA, all those like sort of intentionally vulnerable web applications that you can download and play around with. So I went through a lot of those, and I thought, okay, so now I finally know what I really want to do. And so I started applying for internships, and I was lucky enough to get an internship with Black Duck. At that stage, we were a separate company. I'll talk about that in a bit more detail later. But yeah, so I had a year-long internship, then continued working through the summer, and then following that, I worked part-time through the last year of my degree, and then I was lucky enough to be offered a job with the company. So my kind of main area of interest is just automating vulnerability testing, be it through kind of like traditional DevOps tools like Ansible, Puppet. A lot of the time I just use Bash because I think it's nicer. Well, maybe not nicer, but easier. So that's kind of just a little bit about me. So now I'm going to talk a bit about Synopsys. So I think this is the second year that Synopsys have done an opening keynote. So how many people have heard of us? I guess probably just a quick Yeah, tons. Right, so if you ask that question anywhere else, people would be looking at you with blank faces, because Synopsys, I don't think, are super, at least in Northern Ireland, they're not super well known in the security space. They're known mainly as an EDA company, so electronic design automation, building the kind of software that engineers would use to test and design, chips and PCBs, things like that. So the company is split into 3 divisions. We've got the Silicon Design Verification, Silicon IP, and then the Software Integrity Group that I mentioned before. We've got around 13,000 employees worldwide, and the company has been going for 30 years, which in the tech industry is a long, long time. So we were acquired by Synopsys in December 2017, and more recently, the Cybersecurity Research Center has been set up. That was about a year ago, I think. There's 4 research labs. So there's ourselves in Belfast, BDSR team. Then there's the guys over in Boston. So they are the KB team. So that's the centralized database where we have all our licensing and vulnerability information. There's the Calgary office. They're focusing on looking at code patterns that tend to point towards something being insecure. And then lastly, we have the team in Oulu in Finland, and they're the guys that discovered Heartbleed, and I'll talk a bit about that a little bit later on. So here is the plan for today. I'm going to start off with just a generic sort of explanation of what open source is, some of its benefits and downsides, followed by some of the challenges in vulnerability reporting, which will just be me complaining. Then I'll talk about the OSRA report, which is a report we create, we being the Cybersecurity Research Center. Then Heartbleed, very high-profile public vulnerability that I'm sure many of you have heard of, if not all of you. Then we'll talk about some of the different support models. How does commercial software differ from open source in how patches are distributed and so on? Then sort of common remediation strategies. So what do you do if you have open source in your code base and it is vulnerable? Then I'll talk a bit about what BDSR specifically do and the Polaris platform, and finishing off with a little discussion of Apache Struts and the major breach that happened, the Equifax breach. So here is a nice generic Wikipedia definition of what open source is: type of computer software with its source code made available with a license which the copyright holder provides the rights to study, change, and distribute the software to anyone and for any purpose. So you can't really talk about open source without talking about Richard Stallman, and he probably wouldn't like that very much. So Richard Stallman worked as a programmer at the AI department at MIT in the 70s and 80s. In 1980, Xerox donated a laser printer to the department. Their previous printer had an issue where it would always jam, and to get around this, or at least kind of lessen the effects, they modified the driver code of the printer so that it would send a message to an individual user saying the printer is jammed, can somebody come and clear it? So he thought, okay, well, we've got this new printer, I can just look in the source code and modify it and add this in. And he got in contact with Xerox. And of course they said, no, you can't do that. That's commercial software. We're trying to make money. Go away, basically. So in response to that, he was sort of appalled by this idea that you didn't have the freedom to just modify software as you wanted. And he decided to create his own free software libre sort of idea, operating system, and make it available for anybody to use. And, well, the compiler's done and it's really good. The rest of it, not quite there yet. So I'll talk a bit about the benefits of open source software. Before that, I want to just talk about how it's changed. So that was his sort of vision for it, was something that would be free, kind of no restrictions placed on it. Anybody could use it. But nowadays, open source has changed a lot. So when open source projects reach a sort of critical mass, what tends to happen is companies will start to get involved, and there'll be some sort of commercial aspect added to it. So this might be in the form of paid support. It could be training on the software. It could be features that are kind of paywalled. And there's so many examples of this, Chef, Puppet, Nginx, even things you wouldn't think about like curl. There's actually a company behind that, kind of responsible for the administration of that project. So it's estimated that maybe 50% of the code contributed to open source projects is written by paid employees working for a company, doing so during 9 to 5 hours. And that does make sense if you think about it. The idea that something as huge as this, something that's reached this kind of scale, could be maintained by, hobbyists in their spare time. It's not really practical or realistic. So some of the benefits, really obvious one is it's cheaper. That's not to say that open source is necessarily always free. But if it's paid, it's almost always cheaper than its commercial equivalent. It's sort of, it's estimated that if companies actually had to pay for this, it would probably cost them about $60 billion a year. It's also faster to get the product released, because you're not building things up from scratch. There's software we just take for granted that we can get it. No company would ever think to build a web server from scratch. Well, obviously some would, but it's not the kind of standard practice anyway. Then there's the flexibility that open source gives you. You can, if you're using a component that doesn't fit your purposes, you can swap it out. Obviously, sometimes that's easier said than done, but it's certainly easier than it would be with a commercial product where you're tied into a contract. Then there's the innovation aspect of open source. So you're kind of leveraging the expertise of a very passionate community of people who are, really into this project, and they want it to be good, not just because their manager says you need to do this, but because they feel personally that they want to contribute something to it. And then the big one that we were interested in, faster patches. Generally, open source projects patch faster. Now, whether that means they are more secure as a result, because there's also the rest of the workflow where an organization has to actually apply the patches. That might be a whole different story. So open source software, not without risks. The first big one is projects become unmaintained over time. So if you have projects that are written with older technologies, older languages, then those kind of just naturally lose support over time, because it's a very dynamic industry. We're always looking at the next kind of flavor of the month language or whatever, and that means the pool of developers is very much reduced. Then you also have things like internal issues, internal politics of open source projects, which might either kind of derail the project and take it in a direction that you don't like, or it might mean there's like a mass exodus of developers that just dries up resources and means that the project can't move forward with the speed that it did before. So then there's the huge issue of licensing. I'm certainly not a lawyer. I'm very glad I'm not one. And there's a lot to the whole topic of open source license conflicts. So some of the major open source licenses that you may or may not have heard of, there's the GPL, MIT, there's the Apache 2 license, and there's many variants of all of those. But we have, so in our knowledge base, we have in and around 2,500 different licenses, although in practice, something like 20 of those cover like 98% of what's actually there. There's some really, really strange ones. There's the chicken dance license, where if you're using the software, then you have to do the chicken dance on social media. Presumably that gets enforced. Then you've got the beerware license, where if you like the project, then you can buy the maintainer beer, which I think sounds like a good idea. And then my personal favorite, which is the hot potato license, where whoever the last contributor was, whoever pushed the last commit, they take over as the owner of the project. So I think that can have some really interesting effects. So yeah, there's a ton of different licenses. Broadly speaking, there's two kind of categories. There's permissive licenses and there's copyleft. So permissive is much more kind of permissive. Yeah, that's the best word for it, isn't it? So it allows people to do largely what they want with the project. But then copyleft, which maybe I just didn't pick this up, but copyleft, opposite of copyright. Yeah. So GPL is a good example of that. And it's one where if you use that software within your code base, then you have to open source all the code for whatever binaries you distribute. You also have to distribute the source. So yeah, it's a huge issue. In the Osler report, about 95% of the vulnerabilities, of the open source that was in use, people didn't even know about it. Companies weren't even aware of it. Another massive problem is lack of support. So obviously, if you have a paid contract with a vendor, then the buck sort of stops with them. If you're having a problem, they have to sort it out. Not true of open source software. Can be very time consuming and frustrating to install, and it's made worse by the fact that documentation doesn't always get kept up to date, and it's not always accurate, or there's nuances between different distributions that aren't kind of made clear. And then the other sort of issue with support is the long-term cost of having to maintain this. So bug fixes and obviously vulnerabilities. And vulnerabilities is the big one, the reason why I'm standing here today. About 11 disclosed every day, and that number is just going up and up and up. So here comes the complaining slide. So the community of people that work on vulnerability research in open source, it's a range. It's a sort of broad range. You've got academics, white hat hackers, just members of the open source community in general, and the quality of reporting varies quite a bit, to be kind. And one of the big issues, I think, just for security as an industry in general, is just trying to accurately reflect what's actually going on with the vulnerability. There's sort of two extremes. You can say it's really minor, don't worry about it, or just, blow it completely out of proportion, and neither of them really help, especially for the people that actually have to deal with it, because if you just say everything is 10, red, top priority, then how do you ever triage anything or deal with it in a scalable way? There's a huge class of vulnerabilities which are things like use after free, double freeze, all sorts of memory corruption issues in languages like C, C++. And one thing you often see is this is definitely remote code execution, 100%. And I mean, it is possible, certainly, but I think to say that it's like a guaranteed thing is a mistake. And I can see why people do it. They're just trying to cover themselves. You know, if it's discovered that it was possible, then obviously that's not good for you. But yeah, I think just having like a more accurate picture of what's going on is important. And then there's a related one, which is the sort of class of command injection vulnerabilities, where you can execute commands on the target server. And the problem with those is they say, you know, do anything, delete the file system, whatever. But, you know, if tools, and I'm not saying they always are, but if the tooling is set up well, you know, by a competent sysadmin, then things shouldn't really be running as root, and things should have, you know, permissions that are paired back to whatever is actually necessary for the application to work. Not always the case in practice. There's the whole issue of CVEs. So I'm definitely not the first person to complain about CVEs and the whole process of how CVEs are handled. So you have, how many people have heard of NVD? Okay, a few. Yeah, so NVD, this massive online database of standards-based vulnerability information, it is run by the US government, and it gets its funding from the Department of Homeland Security. And it doesn't get a lot of funding, and that's pretty obvious if you sort of read through some of the reports. There's a lot of missing information or just downright incorrect information. The whole concept of having one CVE per issue seems like a good one in theory, but in practice it doesn't really work. It doesn't necessarily always work, because say you have a web application, no output encoding whatsoever, so there's cross-site scripting everywhere. So you'd say, right, well, that's just one massive issue with that application. What happens then if the vendor fixes certain parameters on certain pages but not others? Then tracking it all gets really complicated. And there's the whole issue of, if there's a regression, how do you track that? Does it get its own CVE? At the moment, sometimes it does, sometimes it doesn't. There's no clear reason why. So it's kind of messy. And sometimes you'll get periods where NVD just aren't updating. The reports just don't make sense. Like, you can read them over and over again and just think, I don't know what this is trying to actually say. Yeah, so, and then related to CVEs have become kind of like something that people use to pad their resumes. And I'm not blaming anybody. Like, I would definitely do that if I got a CVE. I would think, oh, this is great. But it makes triage hard, because people are so focused on, I really need to get a CVE. Never mind if it's this really like convoluted scenario. What I'm trying to do is just find something that's gonna, give me more credibility. Then you have embargoed information, as well as lack of support from vendors. So a lot of information you have, like the core product is still open source. There's no restrictions about what people can and can't do with it, but the information is still kept out of the public eye by the vendor for a period after the responsible disclosure process has been followed. And then just talk a little bit about vendor cooperation. So sometimes vendors are not always very helpful in providing security fixes in a timely way. There's the whole problem of just researchers trying to get in contact with a vendor. The vendor doesn't respond, either because they just think this isn't really an issue, I'm not going to deal with this, or just because they haven't got the time or resources to deal with it. And it just makes the whole process difficult. And what happens then is researchers get frustrated, and then they say, I'm just going to put it out there because it's too big an issue for people not to know about. And then that leads to a whole raft of other issues. So yeah, vendor compliance is a really big deal. So now I'm going to talk about the OSRA report, which is the Open Source Security and Risk Analysis report. And it's created by the Cybersecurity Research Center. It's a it provides a detailed insight into the code quality, the security status, and also the compliance, the license compliance of the application. So OSRA, it covers 1,200 anonymized. So the last one, this is 2018 data for the 2019 release. 1,200 anonymized code bases covering 17 industries with about 71 code bases per industry. So this is a breakdown of the code bases which had open source. So overall, there was 96% that did have open source, but that's so if you eliminate the projects that only had fewer than 1,000 files, then it's more like 99%. So yeah, it's totally ubiquitous. So then this is just showing the sort of per industry breakdown. So you can see that there's fewer in hardware and semiconductors. That's probably because that's a much more regulated area. There's much more strict laws around what you can and can't do. The IoT case is interesting because on the 1st of January this year, there was a bill brought in California, which basically said you have to take reasonable measures to secure IoT devices. Now, what that actually specifically means, reasonable measures, it's hard to know. But it's at least they've pointed to things like no hard-coded passwords, that kind of thing. So open source represented 60% of the code analyzed in 2018, up from 57%. So not a massive change, but noticeable anyway. So as I mentioned before, virtually all open source, 90%, just looking at all of the projects and not filtering out the ones with fewer than 1,000 files. So this is looking again at how much per industry. So you've got obviously enterprise software, as you might expect, is the lowest one. VR and gaming, they have access to software and hardware which they get before anybody else, and specific tools that just wouldn't be widely available. So this is looking at the top 10 open source components. The most popular one there is jQuery. It was found in 56% of code bases, and it was found across virtually every industry. It's almost all JavaScript. The only exceptions being JUnit, which is a Java-based unit testing framework, and JSON.NET, which is JSON library for the .NET framework. So in 2014, the Linux Foundation set up this thing called the Core Infrastructure Initiative. So the idea of that was, particularly off the back of things like Heartbleed, we need some sort of proper support, including financial support, for these pieces of infrastructure that are really critical to kind of the modern, just to the modern world. I think it's not an exaggeration to say. And the following year, they came out with this report called Census One, and it was looking at the security of applications which are critical to a specific distribution. Specifically, it was Debian, but that was focused more on something that's sort of hidden from certainly the user and from many developers. It's not something that you would use in your application code. So they just, I think 2-3 weeks ago maybe, they released another report. It's a preliminary report, so don't take it as gospel. But it was looking at application level libraries and so on. And here are the top 10 libraries. So we have gone from JavaScript to Java. So from bad to worse. The two big ones, Jackson. So Jackson is it's a JSON parsing library. It's very, very widely used. There's a lot of kind of issues around it that I'll talk about in a bit more detail. So then you've got things like Guava, which is sort of just general. It's kind of like a nicer version of the Java standard library. And then a few HTTP components and some logging stuff. And that data, by the way, came from Synopsys as well. And that it was us in partnership with the University of Cambridge and also the Linux Foundation. So here are the top 10 CVEs 2018. 2018 was another record year for vulnerabilities being disclosed. 16,500 listed on NVD. We added about 7,000 or so to the Black Duck knowledge base. And just for comparison, in 2017 there was only about 4,000, so it's a pretty staggering jump. And obviously that's partly just because people are becoming more and more aware of it. But still, it's a really noticeable change. So yeah, just looking at these components, there's Jackson at the top again, 3 different CVEs. There's 2 denial of service issues in Apache Commons file upload. And then you've also got Tomcat. They're also the same class of vulnerability that was in Jackson. So a good chunk of these vulnerabilities are to do with deserialization. So if you are you want to include deserialization in your web application, then you need to be very careful about what kind of input you trust, because it allows attackers to do something called object injection, where they chain together calls from libraries that are on the class path. It's quite a recent strain of attacks. It's really bad because it's a reasonably achievable way to get remote code execution. It's a hard thing to find, but it's an easy thing to exploit. There's a whole suite of tools that do this. It's called WISO Serial. And it makes it sort of point and shoot, even though the actual mechanics of how this thing works are quite complex. So that's a serious issue. Another problem with it is it's not something that you can easily mitigate against. The best way that has been addressed so far, Oracle have actually talked about just removing deserialization completely, but people rely on it, so not likely to happen. And one of the ways to deal with it is to come up with a whitelist, or alternatively a blacklist. The problem with a blacklist is every time it's called a gadget, so it's a library on the class path. Every time a new one comes out, you've got to keep adding them to the blacklist. But by that point, you've already probably been breached, so it's kind of a losing battle. Okay, so now I'm going to talk a bit about Heartbleed. How many people have heard of Heartbleed? Pretty much everybody. Okay, so Heartbleed was a vulnerability in the OpenSSL implementation of part of the DTLS protocol called the Heartbeat extension. It's a really obscure feature that probably at the time a lot of people didn't know about. It's kind of like a keep alive mechanism where you send a message to the server and it sends back a message saying that it's still there, responding. So it's a vulnerability that allows you to steal information from the target server. You can read about 64 kilobytes of data at a time. And it's especially bad because it doesn't leave any kind of trace in the logs. It's very unlikely, especially at the time when it was exploited, that anybody would have a rule set up to detect this. So only those, few people that were like looking at this specific part of the protocol would have caught it. It resulted in community health systems being breached, and about 4.5 million patient records were compromised. So Heartbleed, a big part of the problem with this vulnerability, at the time when it was discovered, OpenSSL had one paid employee and they had something like $2,000 a year in donations. So, this is a really critical thing that so many applications rely on for security. Web servers, email servers, loads of client software all needs working TLS implementations. So this vulnerability, as I mentioned before, was actually independently discovered by Google's security team, but also by a team of researchers at Codenomicon, which has now been acquired by Synopsys. So that's just a bit about Heartbleed. So here's a little XKCD comic explaining how it works. So you say, server, are you still there? Give me back whatever string. But the point is you can specify the length of the string. It doesn't validate that the message you sent and the length you asked for are consistent. So if you ask it to read more, it'll just do it. So then you can see, are you still there? Hat, but I want 500 letters, and it pulls out all this other information. And it's a pretty reliable exploit. That's another side of it. It's obviously a memory handling issue, but it's one of those ones where a lot of the time, if you have an out of bounds read or write, it'll just be a crash. But this is one of those cases where it's actually a reliable exploit that lets you get something useful. So we've got 4 or 5 vulnerabilities. They're all named vulnerabilities. There were named vulnerabilities before Heartbleed, but it really sort of kicked it off in a big way. What they all have in common, though, is they were not found through static or dynamic analysis tools. They were found by manual code review by researchers. So to deal with something like that, to be able to have an application that's, nothing's ever going to be completely secure, but to have a broader range of tools for dealing with that, you need to have the full gamut from static analysis, dynamic analysis, interactive analysis, plus what we at Black Duck call software compositional analysis. So digging down into the dependencies that the project has and looking at the vulnerabilities that are buried many, many, many levels away. So I'm going to look now at some software support models and how that's different between commercial applications and open source ones. So if it's a commercial application, you have a push model. It's passive. You don't have to do anything. The vendor pushes the updates out to you, and you just keep putting them off until finally it just does a sneaky update and you have to update. Then there's the kind of opposite of that, the pull model, the way an open source project operates. So you are responsible for pulling down new versions, patches, workarounds, maintaining the software. So it's good to have agency, but also it's a lot of work. So there's, benefits and downsides to both. So if there's open source software in your code base, there's security vulnerabilities. How do you actually deal with it? So the most common approach taken by organizations is just rip and replace. If you've got a vulnerable component, get rid of it, move to a later version, go to a completely separate component that gives you the same functionality. Black Duck run a service called OpenHub, which is basically indexing all open source, and they provide suggestions on alternative projects which give you the same functionality, but just a different project. So rip and replace sounds easy. In practice, not so easy. I think it's very easy for us as researchers to just say, hurry up and fix your code. Why have you not applied this patch? But it's not trivial to upgrade. Updates are painful. They take time. Testing has to happen. It's resource intensive. It's not just an easy one-step thing. So vendors will often say, upgrade to latest stable version, assuming that there is a different LTS and stable, if there are different release lines, that's fine. What if you're using a project that just has a single version line and that's it? So I was kind of bitten by this recently. I was building a Django app, and it was just for a hobby project, and I was trying to deploy it, and I was using Unicorn, proxy passing from Nginx to Unicorn, and couldn't get Unicorn to work. The daemon just wouldn't start. Thought, I don't know this stack, I'm probably just being stupid. There's some log file, there's some config file somewhere that's got some stupid typo in it. Spent hours and hours and hours and got absolutely nowhere with it. Couldn't find anything online. Just went onto the Unicorn GitHub page, and I was just refreshing the issues, just seeing if there was anything relevant to it, because this was quite a recent release. I think it was like a few days maybe prior to me doing this, and I noticed something, and it was the exact issue I was having, and I watched it like being fixed. I watched the comments go past as the maintainer said, yeah, it's this. It was like a Linux only issue with sockets, like it was sort of error that just doesn't give you any clue as to what's wrong. So that was and that was nice. That happens to you kind of in your free time, and not like when you're trying to deliver something to a deadline. But yeah, so if there's a long-term stable release, that's great, but there may not always be. So you can get stuck in that situation where something like that happens. So that's the rip and replace strategy. Then there's applying patches. This sounds like a more viable way to do things, because at least if you're applying patches, you're making minimal changes. But in practice, maintaining that's a nightmare. You might have a company with an internal fork of project with, little bug fixes, little patches, modifications. And over time, that just gets increasingly out of sync with the upstream. And then whenever that release reaches end of life, where you absolutely have to upgrade, then it's pain trying to get everything moved across. So then the other aspect of that is, depends whether or not you can actually patch the software yourself. If it's, say, something written in C or C++, you have to apply the patch manually. Hopefully it applies cleanly. If it doesn't, then you're into digging around in the code trying to fix what's wrong. Maybe it's not your sort of domain, and quickly it turns into something that's kind of a much bigger job than it should be. And often, because of these factors, companies are just paralyzed into doing nothing. There's no obvious path forward. And sometimes if a version upgrade is going to be particularly damaging in terms of broken features, they'll just say, let's just take the risk. It's a bigger risk to have things be down for such a long time and have such a huge interruption to the service. These vulnerabilities, maybe some of them are lower severity. We'll just hope for the best. Not a good strategy, but sometimes there's no other choice. And then lastly, we have workarounds. So just any kind of non-permanent mitigation. So that might be just a change to a config file, or turning a feature off, or applying just some kind of, could be an IDS rule, could be web application firewall rule, just something to stop the bleeding essentially, and keep you somewhat secure for a little bit longer. So how do companies deal with open source vulnerabilities now? There's a few different approaches that are taken. The first kind of big one is to try and discover them yourself. But this is really difficult. If you have a small team who are handling kind of the DevOps side of things, they may or may not have security background. It may just be too laborious and time consuming to accurately test things. And this tends to occur at the end of the software development lifecycle. So that can cause problems when you realize you're going to have to go back and change the architecture of your application in a major way. So then put it in a big spreadsheet. Obviously, that's not going to work. People forget. Somebody loses the spreadsheet. It doesn't get kept up to date. It's just not a scalable solution. Digging through every single dependency of a dependency of a dependency to check if there might be some vulnerability in it, it's not practical to try and do that by hand. Then you've got periodic scanners like Nexpose, which do sort of dynamic scan of the code. That's one option, but it doesn't scale particularly well. And it's something you have to sort of keep up with it. Or then there's just the approach of we'll do a scan when we can sort of fit it in. And obviously that doesn't always work either. So what can you do to what's one strategy that helps you mitigate against this? So we offer our Black Duck security advisories. These are independent records that are researched by our dedicated team in Black Duck Security Research Belfast. We offer enhanced data. We've got richer technical details, exploit links, proof of concept links, workarounds, and also official vendor-supplied links to patches and vendor upgrades. So those are offered as part of the Black Duck source code compositional analysis tool. And they're also integrated into our larger overall platform, which is called Polaris. So SIG covers a number of different acquisitions, and each of their individual tools are sort of represented under the larger umbrella of Polaris. So you can invoke Polaris either as a IDE plugin. It's called CodeSite, and it brings up like individual vulnerabilities and gives you links to the BDSAs, which give you more detailed mitigation advice and helps an organization triage more effectively. And then there's also the central server, so that allows you to offload all the sort of resource-intensive things to a bigger, better server. So just looking at the kind of individual services that are offered within that, there is Coverity. It's a static analysis tool. It's a very mature and battle-tested tool. It was used by CERN to test the code for the Large Hadron Collider. It was also used by NASA's Jet Propulsion Laboratory for the Mars rover. And then, as well as that, we have our own tool, Black Duck Source Code Compositional Analysis, also integrated as part of Polaris. Then there's Seeker. That's an interactive application security testing tool for web applications. It finds vulnerabilities and other sources of data leakage. So just last month, we acquired a company called Tinfoil Security, and they provide DAST tools as well as API testing. And with that, we've kind of reached like the full gamut of different application security testing tools. So giving you the best possible chance of keeping your software secure. And I'm just going to wrap up now. I'm sure you're thoroughly sick of listening to me talk. With a little discussion of Apache Struts and Equifax. So how many people have heard of Equifax? Okay, quite a few. So in America, Equifax is like a household name, one of the top 3 commercial credit reporting agencies. In 2017, they had a major breach where I think something in the region of 145 million records were stolen. So people's personal information full names, driver's licenses, dates of birth, addresses. A small subset of those records were credit card numbers. And so according to Equifax, the issue was attackers looking at an external complaints portal. They used this CV 2017-5638. It's an issue in Apache Struts in the Jakarta multi-part parser. It's a remote code execution vulnerability. And so Struts it's a really old web framework. It's an MVC framework. The initial release was in May 2000. So yeah, been going for ages. And one of the issues with Struts and why these kind of remote code execution problems are so kind of prevalent is that they have this. One of their dependencies is this library called Object Graph Navigation Language, also made by Apache, and that lets you inspect the properties of objects at runtime, which for an attacker is a very powerful tool, sort of in the same class as the object injection vulnerabilities I was talking about earlier. The patch was available, so in fact I think that Struts had a security company in a matter of months before the breach happened. So this isn't like Heartbleed and those sort of other named vulnerabilities where, no one really was aware, there was no patch, there was no obvious strategy for mitigation. There was something that could have been done about this. So after the breach happened, one of our researchers was looking into a particular remote code execution issue, different one, in Struts, and they noticed that there was a discrepancy between the versions that they were testing and finding to be vulnerable and the ones reported by Apache. And that led us to the question of maybe this is, a more widespread phenomenon where vendors are saying these are the fixed versions, these are the vulnerable versions, but actually that may not be completely accurate. So I think 23 new vulnerable versions were discovered from that research, and it led us to kick off this larger scale verification project where we wanted to test if the Apache advisories were actually accurate. This resulted in us building 115 versions of Struts. That's about a decade's worth of software, so that was a major challenge in terms of infrastructure. If you want to read a bit more about that and the nightmares we had with POM files, then you can do that on the Synopsys blog. So we discovered 24 of the 57 official Apache advisories were incorrect. There were 61 missing vulnerable versions, and we communicated our findings to the Struts project, and they were very obliging and they were very helpful through the process. They released a new advisory detailing our findings, and they also updated all their old original advisories. And we just want to say thank you to Struts for helping us out and working with us. So just to sort of wrap up, it's been nice for Black Duck to try and contribute something back to open source. We also have our own organization page on GitHub, and there's lots of plugins and tools that relate to our products that you can look into if you're interested. That's pretty much everything I wanted to say. There's my email address. You can also add me on LinkedIn if you'd like to. I don't really use Twitter. I have an account. I don't think I've ever actually tweeted. I'm just not a big fan of social media in general. Like if I could just get rid of my phone, it would be amazing. But yeah, if you've questions, then come up and chat to us at the end. We will be with the other sponsors just outside reception if you want to talk about open source, cybersecurity, programming, whatever. Yeah, so that's me. Thanks very much for listening.